This video might take a lot of time because we still need to determine whether this is a Bernoulli equation, and there is a lot of processes, or there are a lot of processes that involves that. At the same time, of course, our goal is to solve for the Bernoulli equation. We are going to proceed or pass through the idea of linear equation. So let's start with distributing or let's divide both sides first with dx, so that we could have dy over dx as part of the standard form of Bernoulli equation. So by multiplying both sides, this will just be y times 6y squared minus x minus 1. Dx will be removed, plus 2x. Then we have here dy over dx equal to 0. Then distributing y in our first term, we have 6y cubed minus xy minus y plus 2x dy over dx equal to 0. Let's move the rest of the items on the other side. But first, we are going to pair this here, because this has y with what do you call this one? Negative, exponent of 1. Moving this on the other side and factoring y here, you will have y or negative y. Let's just use negative y. If you would like to, you could also use positive y, but let me just use negative y. So you have x plus 1 as we take negative to that, and then plus 2x dy over dx, and you have negative 6y cubed as I moved that on the other side already. Rearranging all of these terms, you will have 2x dy over dx to get the standard form minus x plus 1y is equal to negative 6y cubed. To finish this, the standard form of Bernoulli equation is where this is equal to 1. The first term should be equal, or the coefficient is equal to 1. So let's try to divide or multiply both sides by 1 over 2x. So dy over dx is minus x plus 1 over 2x y, if I'm correct. And then equal to, that's negative 3 over xy cubed. 6 divided by 2 is 3, negative 3, that's correct. X is in the denominator. This is now the standard form of this Bernoulli equation, or this equation in terms of Bernoulli equation, where n is 3, p of x is this entire expression, the negative of x plus 1 over 2x, and our f of x is negative 3 over x. Okay? Since we are now sure it's a Bernoulli equation, let's proceed to the first step of solving Bernoulli equation. You have, I'm just going to rewrite it here, minus x plus 1, 2x, you have here y is equal to negative 3x over x, so rather y cubed. We're going to remove this by multiplying y to the power of negative 3 on all parts of the equation, because you would like to retain only the function of x on the right hand side. That's the first step. So you have y to the power of negative 3 dy over dx minus the same x plus 1 over 2x, but this y, you have your y to the power of negative 3, so you're following the laws of exponents, so add them. 1 minus 3 is negative 2, and you have your negative 3 over x. Okay, so the next step here is we are going to make this, or assign a variable with exponent 1, so that we could get closer to a linear equation. Let y, let us use z for y to the power of negative 2. Okay, and with that, as we take its first derivative, you have negative 2 y negative 3 dy. This is also what is expressed here. So if we're going to divide both sides by negative 2, so y negative 3 dy is equal to negative 1/2 of dz. Okay, so this being in mind, our final equation now, okay, hopefully you can still see my scribbles here. Let me write it here. So this will become this expression, negative 1/2. So negative 1/2 of dz over dx. Dx is still there, minus d is still here over 2x, and your y to the power of negative 2 will be expressed as z, equal to negative 3 over x. We are not yet done with this because the standard form should contain only 1 here. So we'll be multiplying both sides by negative 2. This means we have dz over dx. We have plus, you have 2 in here, cancel. So you have x plus 1 over x. Okay, that's positive now because we multiply it with negative 2. And then the next part is you will have here, sorry, let me check if it's really negative. Negative at the top. Yeah, negative. Okay. Positive already is equal to positive 6 over 6 over x. Okay, so that's how what will happen right now because we are done multiplying by negative 2. So with this time, sorry, there's a z. That's what I'm looking for. Sorry, that's why I feel that there's lacking. So with this, we can now say that our p sub 1 of x to differentiate with the p, so a p of x here as well as f of x is equal to this expression, x plus 1 over x. And our f sub 1 of x is 6 over x. We're going to use this p sub 1 of x for our integrating factor. Mu of x is equal to e to the power of the integral of p sub 1 of x dx. E to the power of the integral of, you will have x plus 1 over x dx. It looks complicated, but if you're going to break that rational expression into x over x plus 1 over x dx, you will get here an expression which is just 1 plus 1 over x dx. And breaking that into two different integrals, you have e to the power of the integral of 1 dx plus the integral of 1 over x dx. So you have e to the power of x, x, plus the natural logarithm of x. Okay, this is the exponent. This is our mu. Sorry for this. Sorry for this. Let me. This is the. This is our mu of x. Just to make this easier, addition of exponents is equivalent to the product of the same base, e to the natural logarithm of x. Okay, because you will get here just a result of e to the power of x times x, or x e to the power of x. This is our integrating factor. Okay, it's easier to look at than this. We are going to use the integrating factor here because in our expression, again, integrating factor is x times e to the power of x. So we'll have here this expression. Sorry for that. I'm adjusting my space. So you have mu of x of z, not y, is equal to mu of x f sub 1 of x dx. I told you earlier this will be very long because of the additional steps needed earlier to verify for Bernoulli equation. Our integrating factor is this again at the bottom. So you have x e to the power of x and then z is equal to x e to the power of x times your f sub 1 of x, which is this one here, times 6 over x dx. So x e to the power of x z is equal to, this will be removed, we can take out 6 e to the power of x dx, which will give us x e to the power of x z is equal to 6, and the integral of that is e to the power of x plus c. Okay, we're almost there. The next thing here is to isolate z. So we're going to divide or multiply both sides by x times e to the power of x. So this will be cancelled here, leaving z. Okay, equal to, as we multiply that here, you will have 6 over x, as e to the power of x is cancelled, plus c over x e to the power of x. Okay, or if you don't want to cancel that, so that you can actually combine them later into one expression, you can have it's easier for us to look at this because it's still z, 6 e to the power of x plus c all over x e to the power of x. We're using this instead of the answer earlier because z is not yet the final answer. We can represent it y to the power of negative 2. So you have, okay, y to the power of negative 2, that's our z, equal to 6 e to the power of power of x plus c over x e to the power of x. This is actually 1 over y squared. So you have still equal to 6 e to the power of x plus c over x e to the power of x. Reciprocate that, y squared is equal to x e to the power of x over 6 e to the power of x plus c. This is now the final answer for our solution. Or if you'd like to take the square root to really get y, you have this final form. But other references will just accept this answer, but nevertheless they are just the same. Okay, so this is the result for this given Bernoulli equation. We tried to verify it first earlier before starting with our process, but definitely we still arrived to an answer. Thank you very much for watching.